I'm going to do one more example with p-value. This experiment says in 1995, 40% of adults aged 18 or older reported that they had a great deal of confidence in the public schools. In 2005, a poll in which 372 of 1,004 adults aged 18 or older stated that they had a great deal of confidence in the public schools. So, does the evidence suggest at a alpha equal 0.05 significance level that the proportion of adults aged 18 or older having a great deal of confidence in the public schools is significantly lower in 2005 than the 1995 proportion? So our null and alternative hypothesis, well, first of all, let's take a look at the information that we have here. Our p sub 0 is 0.4. That's what we're testing. Our x is 372, and our n equals 1004, which makes p hat equal 372 over 1004, and we can find that value here. As about 0.371. All right, so the other piece of information that we have in the lower group here we're given our significance level, alpha is 0.05. And we're also told to determine if we find that it's significantly lower in 2005 than our 1995 proportion. That's all the information we have. Well, we're dealing with a proportion there, and we've determined our p sub 0, so our null hypothesis, HO, is that p equals 0.4. That's if there's no change whatsoever. Our alternative is that our p is strictly less than 0.4. We're looking for significantly lower. Now, it could turn out that it's actually much higher, but we would go with our default of just equaling 0.4. However, given our p hat is 0.371, clearly that can't be the case. Okay, so we're going to use the p-value method here. We have a large enough sample size, so we can find n times p hat, which is just x. And that's 372. That's certainly at least 15. And our q is going to be even larger than that. So we should be good as far as large sample for proportion. This means that we're going to use one prop z test. One prop standing for one proportion, we're only talking about 1p here. We always use a z for the proportion tests, and we're doing a test, not a confidence interval, so that's what we're going to use. So that means we go stat, tests, and then one prop z test. So let's do that. Stat, arrow over to tests. One prop z test appears to be number 5 there. Hit enter. Well, the things it wants. P sub 0, which we determined to be 0.4. So let's put in 0.4. Our x is 372. The number of successes, 372. Our n, 1004. That is our sample size. Again, this next choice is very important. We have to look to the alternative hypothesis. We're using the less than symbol, so we need to choose the second one, the one in the middle. Hit enter. choose one of the other two, we're going to get a bad p-value. And we go to calculate. Now there's a bit of information here. We're given the z, that's our test statistic. We would use that for the traditional method, classical method. Then we have p, and then we have p hat. Well, we already know p hat is 0.371, and that's clearly this number here. We've already calculated that. So this lone p under the z has got to be our p-value. So the p-value is 0.028. Well, how does that compare to alpha? Alpha is up here at 0.05. That's less than or equal to 0.05, which is alpha. Well, when our p is low, the null must go is kind of the little rhyme for it. So we reject again. This means we do have evidence that the proportion is lower in, what was it, 2005 than in 1995.